Okay. Okay, Ash? Excellent. Okay. Hello, everybody, and welcome to this BEIS Nuclear Innovation Programme Suppliers event. My name's Ray Chegwin. I lead for nuclear at the KTN. I'd like to introduce you to my colleagues. You met Natasha on the registration desk. Natasha will be helping out with the roving mic for Q&A a bit later. Mike in the room there is our moderator for our webcast. So welcome to those who are hopefully joining us via webcast. As I say, we will be recording this event, sending out all the information later. So for those joining us via webcast, please say hello to Mike via your chat function and type in all your questions, and we'll make sure we will get those out during the Q&A sessions. Before we get into the agenda, the usual housekeeping sort of stuff, phones please to silent or off. Food and facilities, the toilets are by the lifts and they're on every floor, so if they're busy you can go, I think, up to the full floor, or we have floors, or etc. venues have floors 1, 2, 3 and 4. The lunch will be served at 1 p.m. We've been told it won't be served before 1 p.m. because you can see there's another conference or another event going on next door. That said, if we do finish before 1, and we have plenty of time this morning, if we do finish before 1, we can always go outside, go up to the second floor, help yourself to coffees and continue networking there, and then come down for your lunch at 1 p.m. So. Right, without further ado then, we'll just get into the agenda. So after I finish here, I'll invite Cy Dilks up from BEIS to just set the scene and also provide an introduction. Then we'll invite Phil Rogers from NIRO. He'll give an overview really of the Nuclear Innovation Programme. So you can see, especially for those of you who are new to the Nuclear Innovation Programme, you can see how this particular phase of the programme sits in within the overall programme. Phil will speak for roughly 10 minutes, 15 minutes or so, and then we'll get to hear of some of the existing advanced manufacturing and materials projects, the 2A projects. We'll be hearing from Mike Blackmore at Sheffield Forge Masters, Jamie Wilgrass at Camel Laird, and Mark Chevalier from EDF Energy. Again, we'll have plenty of time, and I think, as I say, particularly for those of you who are new to the programme, but equally to those of you involved with the programme, it's really good to see what progress has been made on the projects. I know I'm certainly looking forward to an update. Please save your questions for each presenter till the end of that session, because what we'd like to do then is bring the presenters back, take a seat, and then we'll have a short Q&A session at the end. So again, for those of you joining via the webcast, type your questions into Mike, and we'll make sure that we will come to you as well. Following that, we'll then get into the real details about the current call. So Cy Dilks and Will Ludlam will go through and brief you through the call, looking at the objectives and eligibility and all that good stuff. And again, at the end of that session, there'll be plenty of time for questions, and I'm sure you'll have quite a few. And as I say, then basically we'll break. If it brings us up to 1 o'clock, fine. If it brings us up a bit shorter, as I say, we can move out. But that brings, if you like, we'll finish formally at 1 o'clock or thereabouts. That's when the webcast will finish. We will stop recordings. Then we can get into proper lunch and networking stuff. We've got the venue till 3 o'clock, so don't feel rushed to leave. But we'll officially close at 1 p.m. As I say, I'll say again at the end, but all this has been recorded, the slides, the delegate lists, and apologies for the late delivery of the agendas, etc., couriers. So all that will be made available to you. We'll send that out. You'll get an email from Natasha again, like you did via registration, with all the links to the recordings and the slides, etc. Probably, it will be early next week, probably by latest close of play on Tuesday. So that's it from me. Yeah, I'll be popping up and again now and again through the day, but for now, I'd like to introduce SciDilks.
Thank you very much, Ray. So I'm SciDilks. I head up the Nuclear and Renewable Innovation Programs at BEIS. And I'm just here to give you a bit of context and hopefully get you a bit enthused about the day. So the launch event today and the program we're running is slightly later than we envisaged. We were hoping to do this autumn last year, but a small election got in the way, and that has a habit of just shoving everything to the right. So apologies that this is not November, but we're on a tight time schedule, and I'll explain why a bit later. Advanced materials and manufacture is important to us. It's a key part of the nuclear innovation program. If we're going to design new technologies, we need new ways of building them, and we need to do them consistently and faster and bring down the cost. So this is right at the core of everything that we're trying to deliver. The response we got from the 2A phase of this that we launched last January was very, very pleasing. We were oversubscribed, and it kicked off a lot of appetite later in the year from people asking us if we were going to do it again. So yes, we are. Just give you something I learnt earlier this week randomly about the importance of this kind of manufacturing and construction we're going. Portland cement. Facts I never knew about Portland cement. If you take all of the developed nations in the world and their CO2 output from industry, if all the Portland cement that went into concrete was produced by one country, that country would be the third highest producer of CO2. It accounts for 8% of the industrial outputs of CO2. So if we can find a way of building things in concrete that don't use that, we are an awful lot of the way towards net zero. With regards to this program, we are about halfway through the Advanced Manufacturing and Materials program. It's a milestone for us. We launched the first phase of this phase, 2A, last January. And a little later in the agenda, you are going to hear from the successful applicants that got into that and kicked off their work last summer and autumn. So they are racing ahead, they're getting stuff done, and they're going to tell you about that today. We're then going to give you a little bit of information about the thing that we launched 3 weeks ago. A lot more detail about that. It's both wider and narrower, but Will explain that. And then the important bit, there's going to be lunch. But it's not the lunch that's important. It's for you to go and talk to each other. After you've heard what we've had to say, and you've heard what the 2A candidates have got to say, go out there, talk to each other, come up with some new ideas. You have 20 days to get a bid into this grant call, which is not a long time. But go and talk to the 2A candidates about not just how they got here, but the joyous bureaucracy you have to get through if you are successful to actually get money out of us, because they have tales to tell and scars to show you. It's interesting and useful for you to know that, so you are going into this eyes open. The financial due diligence is not a pleasant experience, but it's essential. So my main message to leave you with is time is tight, and we apologise for that. This call is going to finish on the 19th of February. That then gives us just enough time to down select and assess the bids, do the financial due diligence, and get the grant agreements in place for you to start work on the 1st of April. And that will give you a shot at 12 months worth of work. Our money runs out on the 31st of March 2021. Now you can carry on doing stuff after that, but we can't pay you for it. So we want a good run at giving you the maximum amount of time to get work done and spend the money. So without that further ado, I will hand over to Phil.
There's a clicker, but it's just a down arrow. It's easy.
Okay, that's fine. Right, morning everybody. Great to see everybody and lots of familiar faces, so I hope you get out of this exactly what you need. I'm here to give you an overview to the strategic higher level of the Nuclear Innovation Programme, which will then lead into more of the focused particular AMM later on. So just a quick intro to NIRO, because I've already spoken to a couple of people who aren't familiar. We are a team that exclusively supports BEIS on elements related to nuclear innovation and research, and we also support NIRAB as well. We have a role directly to BEIS, and we're in the process at the moment of developing what things might look like into the future as well on the programme. No NIRO presentation would be complete without this downward graph, and this goes back to 2011 or 12. It'll be familiar to a lot of people, but this really summarises where research and innovation has led in terms of spend and workforce from the mid-1980s down to where we are today. And this was the resulted in a report that said you have to do something about this. This was about 2011, 2012, which then went through a series of reviews and developments and culminated in the NIRAB recommendations in 2014-15. That is why we have an innovation programme today. Those documents, while quite long and laborious, are important for why we've actually got here today. Importantly, at the same time, of course, we were looking at other energy areas, and BEIS put together the whole of the energy innovation programme, of which the nuclear innovation programme is part. In fact, it's the largest part. It's 180 million between 2016 and 2021. It's there to designed to support the fission industry primarily. So we have a fusion programme. This is the largest public spend on fission for a generation, and is intended to kickstart the UK fission industry and develop us into a net zero economy, but also beyond that to looking at how we can contribute on future technologies. So when making the case for this funding, there were three main milestones that were put together. However, since then, of course, we've got the net zero imperative. And so overlaid against the 2020 target that was written in for the UK to be engaged in collaborative R&D projects, bringing through collaborations with Gen 4 and SMR organisations. Then we have in 2030, we were proposing at the outset to have significant UK design content getting into manufactured parts. That then leads us on to being a much more significant player in an industrial sense internationally in relation to current and future technologies. The important thing at the moment, of course, is net zero. That is a fixed thing. So overlaid over all this, we have to remember that technologies bringing net zero benefit are favourable. In terms of the strategic elements that we consider to build up that then, this is a reminder for many people, but for those of you not familiar, in terms of putting bids together and such like, referring out to some of these benefits and including that into your bid alongside and intertwined with your technical solution is important. Now, this is written into some of the mark scheme, I think, so this is there for you to refer back to. But as a reminder, we're looking for the development of capability and skills in your own organisations and who might be your supply chain across academia and industry. Si's already mentioned the reducing costs. That's a key part. You should be able to demonstrate that your work will enable that now or in the future. Commercial exploitation is a fundamental part of our industrial strategy. The UK wants to have generate wealth, generate growth economically by selling things. So this is a public investment in the winning organisations on this to actually progress as organisations commercially yourselves as well. That's not something that we should shy away from. In terms of international collaborations, well, nuclear is, by virtue of what it is, worldwide. And the UK, in current environment, needs to be outward looking, needs to be looking at who we can leverage capabilities and knowledge from other places. There are R&D programs running elsewhere in the world. There are private investors developing technologies elsewhere in the world. We want you to be engaged in that to help your businesses grow. And finally, of course, the private sector investment, that is fundamental. This is the 35, 65 or similar grant competition. You will need to bring that as part of this. So the The innovation programme as it stands at the moment is active, it's running, we have lots of contracts placed with lots of different organisations who are delivering a whole range of different activities. In that context, please consider how your bid might intertwine with that. This is a programme. This is not, or should not be, a series of discrete different activities. So cross-pollination between the different activities is really worthwhile. That will help, I'm sure, in the delivery of your bid to understand the context and the deployment of whatever technologies you might develop. So in the fuels area, we have a large programme running, now grouped together in fuels and recycling under the Advanced Fuel Cycle programme. You're familiar with AMM. We have obviously the Phase 1 programmes, which have drawn to a conclusion now, and the Phase 2, which are there. However, the Phase 1 programmes are still very relevant, and they may have developed things that you can pick up. They might have developed things, and the companies involved in that might have skills and capabilities that are of value to you. In some other areas, we have digital reactor design. That includes a whole range of things, from specifically looking at digital approaches and tools and data management, right the way through to safety and security. So in there might be elements that you could draw on, refer back to previous dissemination events, such as the Sheffield conference last year, will have presented to you some of the interesting outputs from that you could use. The strategic toolkit is around gathering information that we already have in the UK on Generation 4 systems. And then, of course, you'll be aware of the Advanced Modular Reactor competition that's running in the background as well. And this all, while generated and set up specifically under a nuclear innovation programme in and of its own right, when the nuclear sector deal was released, the advanced manufacturing materials element was brought up to the top again, and we then introduced the 20+12 type concept that's committed to in the nuclear sector deal, of which, if contracts are placed through this, will deliver upon that to its fullest extent and may go beyond that level of investment. So again, in terms of putting your bid together, the sector deal and the benefits that is set to achieve are very relevant. Just for reference, under the Phase 1, these are the topics that were worked upon, so they're there already. I just want to flag those as things that you can pick up that may be relevant to what you're looking to do. Obviously under 2A, we've got the 4 programmes that are running, 3 of which are going to present today, which will give you a better flavour of what the opportunity might be. Okay, so that's pretty much all I have to say. Just to leave that slide up really and remind everybody of the importance of intertwining what you're going to propose technically with the strategic, industrial and energy policy benefits that these projects will need to deliver in order to offer value to the taxpayer, value to BEIS and what we'll be looking for as the projects progress for those that are successful. So thank you for listening. Are we taking questions now, Ray, or are we waiting till later?
Wait till later.
Okay, that's fine. All right, thanks everybody.
Thanks, Phil. Yeah, thanks, Phil. So now we've got to hear about some of those projects. So first of all, I'd like to invite Mike Blackmore from Sheffield Forgemasters. And before Mike starts, nobody picked me up that I didn't even mention fire alarm tests. So there's no test due today. Okay, you're listening. So, but if you should hear an alarm, then we need to leave via the stairs. The exits are by the lifts, and where you came in, and we assemble at the Tony Hancock sculpture across a busy road. But anyway, that's it.
Okay, good morning. My name's Mike Blackmore. I'm a Senior Development Engineer in Sheffield Forgemasters in the R&D department, and I'm responsible for collaborative and funded projects within the company. We were successful, like was mentioned, in bidding into Phase 2A of the Advanced Manufacturing Materials Programme under the BEIS Innovation Programme, and our title of that project was Industrialisation of large-scale electron beam welding for the nuclear industry. So I'll quickly give an introduction to Sheffield Forgemasters, SFEL, if there's anyone in the room who doesn't know what we do. Quick background to the project. overview of the project scope, and a quick update of where we are. Like I said, we've been going since August officially that we got kicked off. So we'll just run through all that. Sorry, is it a bit quieter? Okay, so who are we? We are designers and suppliers of heavy forgings and castings, surprisingly based in Sheffield. Okay, right in the middle of the UK, so we're about 680 staff at present, and we're a one-stop shop for design, manufacturing, inspection, and testing of heavy steel components, and we have on-site capabilities of steel making, forging, foundry casting, machining, offshore design and manufacturing, as well as extensive research and development capabilities. At the moment, we generally export around 60% of our products, and we work in the industries of defence, nuclear, traditional power gen, offshore oil and gas, marine, and construction. I missed there as well. Okay, so just a quick overview of what we have on site. So our melt shop, we have an electric arc furnace where we're capable of melting up to 100 tons of liquid steel at a time. So you're looking at a steel ladle there that's come out of primary steel making. So one of those is around 70 tons worth of steel. With that liquid steel, we're able to send multiple ladles over to our foundry, where we can form sand casting in pits. Up to our current record is a 700-ton liquid steel pour of the largest casting we have currently made. Or we can take that liquid steel and pour it into an ingot mould and allow it to solidify. We can then take that solidified steel and it goes into our forge, where we have two presses. Our largest press, 5 presses, a 10,000-ton press, which is the image here, where we work on the more complicated and larger components that we manufacture. Once those components either come out of the foundry or the forge, they enter into our machine shops. We have 2 machine shops, and again, as an example of the sort of scale of components that we produce on site. Okay, so that's what we can do. So I'll just go a little bit of background of why we applied for a BEIS project. In 2015, we started an Innovate UK project. This was working alongside Rolls-Royce Submarines and TWI, the Welding Institute, where we investigated the feasibility of electron beam welding thick section nuclear grade steels. Okay, so we're looking at the moment at an electron beam weld, so single pass in a test piece. They never look that pretty, but when you take an X-ray shot straight through that, we can see, ignoring the end effects where the beam drops out of the sample, we showed that we could get dense defect-free welds, very high intensity welding, so low heat put into the parent material, and very small tight fusion zones. And we managed to achieve this on site at Forge Masters by bringing the electron beam welding equipment down from TWI up in Middlesbrough, and utilising a local vacuum jacket to facilitate the weld in Forge Masters. So we have an X-ray pit on site where we did that welding. That's what the photograph's showing there. So we took that test piece, which is shown glowing orange on the right there, and subjected it to what we call a quality heat treatment, which is the heat treatment where we essentially set the microstructure and mechanical properties of that component for when it enters into service. And once we heat treated that, we then took a load of mechanical test pieces out of it. The reason we did that was it was predicted that we'd be able to achieve or excel parent material properties within that weld. So if I quickly run through the data, the blue bar graph is showing tensile strength. Blues show the as welded conditions, so straight out of electron beam welding. Green shows the parent material, so what the forging is typically made of. So our typical product, what we would send out every day. And the red is the quality heat treated, so the heat treated electron beam weld. And from the strength, we can basically say it's equivalent to parent, if not ever so slightly better. And from a toughness perspective, so how much energy can that steel absorb if you hit it with a high speed of impact? For pressure vessel applications, you need strength and toughness to resist crack growth. On the right-hand side, that graph is showing the impact behaviour. So the low line with the red dots at the bottom showing low levels of any energy absorption over a wide temperature range is the as-welded condition. But if you heat treat that, there's a thick dotted line throughout all that data, which is basically the heat-treated material. You can get back up to parent toughnesses, and we actually, at lower temperatures, it exceeds the parent material. So really promising for us. So we could produce defect-free welds very quickly in a single shot, and via heat treatment in thick section, we were able to get parent materials back. So that led us to think we had a lot of issues as well. So it was a successful project, but the issues we drew out of that was the equipment and the local vacuum systems weren't up to surviving the longer weld times that the larger size components that we require to manufacture. So we looked at the technology readiness levels and the manufacturing capability levels of the current electron beam welding in the nuclear industry. And if you look at this even for other industries, so aero, automotive, you know, they are way up TRL 9, MCRL 9, they're doing these things day in, day out. You're flying around on electron beam welded structural components in every jet engine that you get into. A lot of your car parts are done with electron beam welding. But for nuclear, we're a little bit behind. So looking at the TRL levels, many years this has been done. It's been done as a bright idea. A lot of lab scale tests has been done to prove, again, electron beam welding of the nuclear alloys can be done. And we did it on a large scale test rig under the Innovate UK project that we had a few years ago. So the next logical step for us was to move up and progress these TRLs, full scale demonstrator components. So you'll see in a sec the scales and types of components we're trying to manufacture to demonstrate this technology is scalable in size. And then that should take us to TRL 6 and then TRL 7, where we'll have service tests, develop a mature product prototyping and move it through. These are the next challenges to come after at the end of our project. And if we look from a manufacturing capability, you could say under the Innovate project and other previous work by the companies, technology sits at around a manufacturing technology readiness level of around 4. We're hoping to push that again into a pre-production phase, again on full-scale equipment and productionized equipment and processes. So again, where we're targeting our phase 2 demonstrator, and then following from that, it would be scale-up and full production facility launch. So who's involved? As I said, Sheffield Forge Masters is the industrial lead on this. We are working with CVE, which is Cambridge Vacuum Engineering, down in Cambridge, who will be supplying and designing the local vacuum electron beam welder and the jackets that we need to perform that welding. We have TWI, the Welding Institute, again down in Cambridge, looking at the process development around the electron beam welding, the inspection and calibration, and NDT. We have Arc Energy Resources down in Gloucester, who are looking to prove out and demonstrate production-ready cladding processes on industrial-sized and full-sized reactor pressure vessel components. Working with the nuclear AMRC again in Sheffield, who are looking at metrology requirements and benchmarking manufacturing processes for us. Manchester University, who are process modelling and doing some materials characterisation. And Cambridge, who are looking at hydrogen modelling, hydrogen evolution in steels, which has a great influence on the heat treatment that you have to give them, and more importantly, the toughness and survivability of that steel. In conjunction with this, we have an industrial steering committee based on many UK companies. So Rolls-Royce Civil Nuclear, so the SMR team, we are engaged with Cavendish Nuclear, Rolls-Royce Submarines, UK AEA, and the MOD, who are all advising on what they'd want to see in terms of outputs and test requirements for the project. Very quick overview, I won't read all this. So we're broken into 7 work packages where every individual has their own responsibility for delivering that work package. Okay, so I'll quickly run through progress to date, where we are with the project. So Cambridge Vacuum Engineering have taken design specs that we devised based on lessons learnt, failure mechanisms that we found during our previous work on the welding system. And they've devised a new beam welder and local jacket, so you can see a test piece and the local jacket surrounding it there. And on the right hand side is the nuclear innovation pressure vessel, the demonstrator that we'll be producing. Okay. So this is in detailed design stage at the moment, so we can start launching manufacturing, and some of the long lead time items now are on order, so manufacturing has kicked off for this. Within Forge Masters, we've looked to see where we're going to implement and how we're going to design an electron beam welding cell. So we've laser surveyed one of our buildings, identified the area where we'll be placing, which is outlined here in the orange, next to the X-ray pit where we did the original project. And we've now started to do the more detailed design, exactly what that welding cell looks like, what it would require in terms of storage, handling room, and the process flow of moving through there. And the little orange shape down the bottom is not so clear. That's a mannequin down there, just to give you a sense of scale. So we are going full size on the demonstrator here, so no longer lab scale pieces. So this is fully, we'll draw out all the issues of handling, assembling, and putting these reactor components together. On top of that, when electrons get fired into pieces of metal at very, very high speeds, they generate a lot of X-rays, so we have to contain that. So there's a lot of health and safety considerations when designing the cell. So we are working through how we design a modular X-ray enclosure. Again, we may not be manufacturing and welding exactly the same thing day in, day out, so we need an X-ray enclosure that will scale and move around with the range of components that might go through that cell. And we're also looking at integration of various sensors onto the local welding jacket to provide validation data for our finite element models that we're developing, as well as providing process control feedback loops. So that includes temperature measurement during welding, strain measurement during welding. We're also again working with TWI to integrate UT testing on the welder as well. So if we do start to see the process drifting, we can either stop or potentially rectify what's going on. Okay, so on the cladding side, so we're cladding some of the pressure vessel components that we'll be manufacturing, but we're also putting in an RPV head that we had again from our Innovate UK project. It's very complicated features, so it's a nice challenge for Arc Energy to work out exactly how we're going to clad these, and again the handling, manipulation and access challenges that there are to achieve in doing these. As I mentioned, we are developing FE modelling capabilities to predict what's going to happen in the components that we're putting together. So what residual stress is going to be sat in there, what microstructures are we going to be forming, ultimately how that might influence the strength and the performance of that when it goes into service. And we're also using the FE models to inform on the tooling heat loads. So what temperatures will the seals have to go up to? So that'll influence the materials that we have to put into there. And again, validation of those models against real embedded thermocouples. Okay, we're also developing fracture toughness testing work on this. Some of the materials that we've proposed, so I've showed some of the high strength and high toughness requirements and properties that we get out of these materials. So they also give the test rigs that have to test them a lot of grief as well. So we're having to redesign a lot of the handling clevises around that and developing the high and low temperature test capability. So we have to be able to heat these samples to test the appropriate ranges for where the materials will have to operate and quantify their toughnesses over that temperature range. So the TWI, like I said, they've been working on the in situ NDE methods that will be integrated into the local vacuum jacket, as well as beam probing and all the process, so the electron beam welding process parameters that will be required to produce a successful defect-free weld. With nuclear MRC, the present work's concentrated on metrology, so basically we've got a load of rings and shells to stack together, and this thing's going to weigh up to 60 tons. So putting those concentrically on top of each other and manipulating them is quite tricky. You need quite a lot of heavy kit, and if they're slightly out, you can't really push them in quite easily. So we need metrology methods that will give us appropriate distance that we can have a standoff, but control quite precisely accurate placement of these assemblies. Okay. So Manchester, specifically looking at the more detailed FE modelling. Forge Masters is looking at more the industrialised, productionised modelling that will only take a day or two to run. Manchester are looking at more of a microstructural modelling capabilities. And we'll be looking at measuring the residual stresses that come out of some of these weldments as well, and then characterising the materials. I mentioned Cambridge, who've started to look at the hydrogen evolution in steel making, so and really critical to bake out of hydrogen out of steels, as I mentioned. So Cambridge are looking exactly where about that hydrogen sits, what mechanisms drives it in getting it out, and can we greatly reduce hydrogen bake out times, because for the large components we can literally have these components in a furnace at 650 degrees C for 2 weeks. So you can imagine the gas bill that generates. Okay. And there's a quick photograph of down in Arc Energy of them demonstrating new capabilities for strip cladding. They're looking at the price sensitivity of consumables and the materials that would go in, but that could be suitable for SMR deployment. Okay, and just a picture of some of their equipment that they have installed and they will be installing to complete this project. And I'll leave it there. Okay.
Thanks, Mike. Lots of detail there. So, as I say, we're getting slides out as quick as we can. So I'm sure people want to see what's in some of those work breakdown structures as well. So I hope you've all been thinking of lots of questions, writing questions down for Mike at the end. Have you got some questions, Mike? No, yeah. Come on, you can do better than that. So next, I'd like to invite up Jamie Wilgress from Camellards.
Speak into the mic. Arrow down. All right. Hello, everyone. I'm Jamie Wilgress, and I'm the project manager for Camellard Energy. So what I'm going to talk to you today about is our AMM Phase 2 contract, but also a little bit of history about our project, or about Camellard. So a bit about Camellard. So you've got here is our site in Birkenhead. It's just on the River Mersey, and it was actually founded in 1820. So that's 200 years ago this year. And in that time period, we've actually constructed 1,350 ships. And even during the war effort, we constructed on average a ship every 21 days. And in today's day and age, that's very difficult to actually contemplate how quick that is. And not only doing that, we were able to repair thousands of ships as well. So I'm going to go through this. I'm going to say a bit more about Camellard. Then I'm going to go through what our AMM Phase 2 project is, what it's called, who we work with, and a very brief overview, because I myself aren't the scientist who's doing the work. But, we'll carry on. Oops, sorry. So what we're doing as part of our project is we're very much the modular build experts. So what you've got here is the aircraft carrier. So the aircraft carrier is such a massive ship that it couldn't just be constructed in one location. We've had to ship out different bits. So the different colors on the image in the middle represents the different companies that are doing the work. So this is actually an old project for us. But you can see that there's the two yellow bits in the middle. They are actually the modules that were built by Camellard. And the actual module on the left is weighing approximately 700 tons. So what we had to do was manufacture these, then lift them up, put them onto a barge, and ship them all the way to the site where they actually combine them together. So this is where our project kind of starts. So we've got all this modular expertise. And what we're doing is, how is this relevant to the AMM Phase 2 project? So what can we learn? What can we take from a shipbuilding industry and implement into the nuclear industry? So the first thing we've done is we've captured all of our processes. So everything from design, build, quality, procurement, and we've taken them and put them into a document. And then we've also created UML diagrams. And the benefit of doing this is anyone who's qualified enough to read the UML diagrams, they can understand that process. So what we're doing then is we're taking the process that we currently do and we're implementing that into our Phase 2 project. Okay? So this is a bit of background. I'm sure at the moment everyone knows the importance of the modular build process, the benefits that go with it, and the whole idea of the AMM Phase 2 is the advancing the materials, but also bringing in your module development. So on the far right-hand side is the kind of flow structure of our project. So nuclear expertise, we're currently working with National Nuclear Laboratory, NNL, and also GE Hitachi. So the purpose of NNL for us is they're kind of like a nuclear consultant. They're coming to us with requirements. They're also giving us upskilling events. They're making sure we create something which is fit for a nuclear installation. We're also working with GE Hitachi, who's got the wealth of knowledge in sodium and also the fuel cells. What we're doing as Camelaird is we're taking that shipbuilding approach, the modular aspect, but we're also using the current supply chain within Camelaird. So it's looking at who supplies us with our materials, who supplies us with our pumps, who supplies us even with our electrical subcontractors. So then hopefully as we go from that, we can go in and we can deliver a project which has your modular methodology. It's fully engaged with the Office of Nuclear Regulation, so they can buy into what we're doing and hopefully deliver something which is more of a cost-effective solution. So with the nuclear expertise, on the far right, we've got the concept drawing of what we're having within our test section. So the idea of our project is we're building 2 rigs, a water rig and a sodium rig. And then we're also working with NNL to give us a functional specification. So what they've done is they've engaged with the thermal hydraulics experts from around the country, but also internationally, and they've come up with a functional specification, what the kit must do. And then we've also worked with GE Hitachi, so they've looked at that functional specification, given us more information, because the idea is we want to be relevant to industry. So what you've got here in this image is a replica of their fuel cell. So they've told us, the geometries, the specification, and we're trying to now manufacture this. So from there, what we're going to do is we're going to implement that test section into 2 different thermal hydraulics rigs. So these are the old concept drawings. At the moment now, we've completed our concept design for the water rig. We're then going to move on to manufacture that, then commission it, and as we're doing that, we're then going to start the design work onto our sodium rig and implement the lessons learned from the water rig into the sodium rig. So the idea of it is we're going to build the first rig, we're going to design it in a modular method. So we can take it apart, we can commission it in-house, disassemble it, transport it, reassemble it, and do a limited on-site commissioning, which hopefully will save time and money. From there, we're going to then move on to our sodium rig. And at the moment, we have parked that idea as of yet because we're concentrating on the water rig first, but we've still gone to HZDR, which is a facility in Germany, and there they've actually got a number of different sodium flow loops. So one's a small sodium flow loop and one's a massive sodium facility where they're trying to do lots of fun and interesting scientific experiments. So what we're trying to do there is go capture all the requirements, capture the knowledge they have, because at the moment in the UK we haven't got many people who are SQEP trained within sodium. So by going there, we're able to understand the different safety requirements that they have. All right. Not only that, we're going to also have a digital twin. So the digital twin will look at the CFD models. It will also look at trying to get all that BIM information and create a BIM model where we have all of the data sheets, all of the manufacturing materials, and everything to do with the maintenance for the rigs there. The idea is that eventually, once we've built them, we will then send them to the NNL facility where they will then run them and do some actual scientific experiments on them. Right, so this is the area where I'm not too familiar with, but essentially, we are building the rig. NNL are developing the CFD model with the help of academia, and from there we're having the model, which will represent the rig, and then the rig will represent reality. So hopefully, the model will represent reality. We can do tests and we can do the verification tests on that. Okay? So then the main purpose of Camelaird within this project is all about the offsite manufacture. So as I described to you earlier, we talked about the aircraft carrier. And what you can see here, the red blocks, that's just a couple of bits of the module which is about to be shipped to Rosyth. You see the square block, that is Bay 13, which is where nuclear AMRC are based. And inside this building is where we're going to manufacture our rigs. Okay? We've got a 3D scan of the building, and we've said that this is roughly what it's going to look like. You've got your sodium rig on the left, and on the right-hand side, you've got your water flow loop. This actually isn't representative of reality, because by the time we're manufacturing our sodium loop, our water rig has left and is being commissioned in NNL. Okay? So the main importance of the modular build is ensuring what leaves Camel Laird is exactly what arrives in working facility in NNL. So what we're doing is we're working with an SME. The SME have worked in the past with renewables, and what they do is they apply smart sensors to areas of wind farms. So when they get transported, they can ensure that the quality of what's left is exactly what, the quality of what arrives is exactly what left the facility. So we're building in a way that's easily to be deconstructed. We're then putting stuff on there which are smart sensors, intelligent fixtures, things which have through life sensors. It's not just about putting a sensor on there, taking some measurements, removing the sensors. It's about putting something on that can be used for the rest of the lifetime of the equipment. That would be like ambient temperatures, vibration checks, etc. But then we're also going to capture the process and create more UML diagrams. So you've not just got your initial UML diagrams, which takes into account the shipbuilding approach, but we're going to implement what we've learned as we've gone through the project. Okay? So then by the time we get to NNL, we can put it back together. The smart sensors will say, you know, everything is as it left. It's also looking at it and saying, well, it hasn't had any major impacts. It hasn't gone under massive stress or strain. So we are confident that if we do this limited on-site commissioning, it is exactly as it was when it left. And then finally, it's all about, this project is all about that cross-sector upskilling. So we're learning about health and safety from the nuclear industry, but we're also trying to help transfer our knowledge from modular building, but also our tolerances, different things that we think are important within shipbuilding may not be relevant to nuclear industry, but we don't know yet until we fully engage. So by working together, we're doing Project Faith, which is our Phase 2 bid, and it's now trying to see what can we do, push forward into the Phase 2B project where you can manufacture on a larger scale. And that is all we have time for, really. So thank you very much, guys. Any questions for me? Thank you. Cheers.
Thanks very much, Jamie. So I hope you do have some questions, and we'll come back to that very soon. So next up is Mark Chevalier from EDF Energy. All right, Mark.
Thanks very much.
Just the down button.
Okay. Right. Good morning. So my name's Mark Chevalier. I work at EDF at Barnwood, down in Gloucester. This presentation is really focusing on the AMR technology and what's going to be required to support the deployment of AMRs in the UK. Also start with a bit of apology. This is all around codes and standards. I don't have any good pictures. So it's not the same as nice pictures of forgers. So it's a bit wordy. I don't have much of an introduction to EDF Energy. I'm sure everyone's familiar with what EDF Energy do. The key information for this is that we are a nuclear operator. We're a nuclear licensee, and we operate the 8 commercial reactors that are operating in the UK at the moment. So that's 7 AGRs, which are twin reactor, high temperature reactors, and Sizewell, and as I'm sure you're all aware, building the new Hinkley Point C, and hopefully in the future Sizewell C as well. So that's what we currently do in the UK, and as I'm sure, as you're all aware, the AGRs are coming towards the end of life in the next 10, 15 years. So EDF Energy will see significant change over that period about how we use our nuclear skills, nuclear capability to support the electricity industry in the future. But currently we're still spending around £18 million a year on R&D in the existing nuclear area. So that's R&D to support our current fleet of nuclear reactors. And that doesn't include the work that we're doing on the future reactors, so things that we're doing around Hinkley Point C, for example. Of that 18 million, a significant percentage is around structural integrity. And that's where I fit into the organisation. So my role within the structural integrity area of EDF Energy is looking after part of that R&D programme. Specifically, I look after the high temperature codes and standards that we use within EDF. So where we spend that £4 million is typically around materials generation, making sure we've got the right material properties to assess our plants, and also developing the methodology that we use. And that's specifically around the R5 assessment methodology and the R6 assessment methodology. So these are assessment procedures that have been developed, well, originally developed by the CEGB 30 to 40 years ago, and we've maintained and developed ever since to make sure they're still at the cutting edge and fit for purpose for assessing the nuclear reactors that we operate. And that's what's required of us by the ONR. So it's a really important part of what we do to demonstrate the continued integrity of our nuclear power plants. So as part of that research programme, we collaborate with a lot of organisations across the UK and internationally, and university partners. And we're involved in several of the Nuclear Innovation Programme Phase 1 activities, namely one which focused on codes and standards that was led by Wood. So we were involved in a sort of governance view there. The Fraser-Nash consultancy project, which looked at residual stresses, probabilistic design, and constraint effects in fracture, so a very technically focused project. And also another project led by Wood that looked at, called Mattia, which looked at validating some of the new test or manufacturing methods that were being developed. So that was around EB welding and also about HIP manufacture. So we were involved in these projects, and when it came to Phase 2, we saw the opportunity to build on what had already happened in Phase 1 and bring in some more things that were building on EDF Energy's expertise. So these were the areas that were identified in Phase 2, or Phase 2A, as it's now seems to be called. And the things that stood out for us where we could contribute the most was around the materials and the codes and standards. And hopefully from my introduction you understand why that's the bits that we thought we could really add the most value. One thing that came out really strongly when this was first put out was around a focus on regulatability. Now, it's probably not a real word, and I'm pretty sure BEIS said it first. But it was all about demonstrating that what you're doing would be able to go into service and acceptable to the ONR. And people have mentioned quite a few times about how they're interacting with the ONR. But we saw a really fundamental problem for AMRs in this area, because we're talking about new methods, well, we're talking about new materials and new methods of manufacture, but actually if you don't know what codes and standards you're driving to, it's very unclear how you will ever demonstrate anything new or any AMR design will actually be acceptable to the regulator. And the problem is that the high temperature codes that are out there currently, either the ASME Section 3 Division 5 and RCC MRX, there are known shortfalls in those assessment procedures. They are not currently accepted by, I know the American NRC wouldn't accept ASME, and I'm pretty certain the ONR wouldn't accept them either. And that's because in the UK, the ONR operate a goal-based regulatory framework. So it's actually the responsibility of the operator or the vendor proposing the design to demonstrate that their reactor is safe. They do not say, if you meet this standards, we will accept it. And that's different from how things work in other countries. So anyone planning to put forward an AMR reactor has to prove to the ONR that the codes and standards they are using are fit for purpose. And as one of the Phase 1 project pointed out, there's quite a few areas in the high temperature codes and standards that are not currently. On top of that, the ONR are slightly more demanding than other regulatory bodies. Not only do they need to demonstrate that components will not fail, they also need to demonstrate that they're defect tolerant. So for the high integrity components, even if there's not a crack there and you've inspected it to show there's not a crack here, you have to demonstrate for the next period of operation that if you've missed something and if there is a crack there, it won't grow and fail. Now, in high temperature, when you've got creep and creep fatigue as an active mechanism, that's a really challenging thing to do, and that's something that's not addressed in any of the design codes that are currently out there. So this, I think, is a really fundamental part of what we're trying to achieve in the Nuclear Innovation Programme. And what this project is trying to do is take a first step towards addressing that. So the project's been called Establishing AMR Structural Integrity Codes and Standards for UK GDA. Very catchy title, but it does exactly what that title says. So the people we've brought together to do this are ourselves, who are leading the project. We've also brought Rolls-Royce and National Nuclear Labs along with us. They're also involved in the development of the codes and standards that EDF Energy look after. We've got some key contract partners, so that's really building on what happened in the Phase 1 Nuclear Innovation Programme, Wood & Fraser Nash. And this project's really trying to exploit the kind of added things that EDF can bring. So we're not currently engaging heavily in, well, I don't think we're engaging at all in AMR technologies as a larger business, but our skills in this area, this very niche area, can, I think, bring a lot. The first one is our knowledge of the UK regulatory framework. We've been operating high temperature plant for 30, 35 years in the UK. So we know what those standards that are required are. And we've also been through GDA ourselves through Hinkley Point C more recently. The AGR operation in the UK is of huge value. So a lot of the shortfalls that were identified in the Phase 1 work that was led by Wood was the result of the operational experience that UK has generated through operation of the AGR. So there's key issues that we've had to address in the lifetime of those plants that still aren't addressed in those design codes. And the other thing is we do have experience of developing methodology. That is effectively what my day job is. And once again, that puts us in a pretty unique position to be able to deliver this programme of work. So the high-level purpose of this is, firstly, as I said, previous shortfalls have been identified. We'll talk a bit in a second about what some of those shortfalls are. So we're aiming to improve the current state of understanding for some of those issues. So they're the technical innovations this programme's trying to deliver. And some of those are threats, i.e. some of those are the shortfalls, but actually there's some opportunities that may be able to result in better designs, optimised designs, better maintenance schedules and things like that. The other thing is making sure that these innovations are actually have impact. So what's well within our control is what we do in the UK. So we'll definitely deliver that in the UK codes and standards. But obviously we also want to influence those other international design codes which are more likely to be used. Third item, and I think this is a real headline deliverable for the project, and this is about guidance on the use of design codes and assessment procedures for anyone considering putting AMR designs through the GDA. So this is not going to be rules, because that's not the way that our regulation system works, but it's going to be guidance about what best practice is, what we know has worked previously, and what we think the shortfalls are potentially that the ONR might query. And finally, high temperature structural integrity assessments is a very niche area. EDF Energy over the past 30 years has felt pretty lonely in this respect, being the only commercial operator of high temperature plant in the world. So this is a real opportunity for us to build up a larger quorum of expertise in the UK to be able to not only support our power plants but support the AMRs, and it also puts us in a unique position in terms of being able to contribute internationally because of that. So this is the breakdown of the project, split into 4 work packs. The first work package is around probabilistic methods, and this is really an opportunity. So design codes at the moment, especially in terms of their structural integrity assessments, are very deterministic in nature, as is R5 and R6. However, if we're moving to improved design and we want to really be confident in the margins of safety that we have, inherently a safety case, i.e. the case you put to the ONR to say that a reactor is safe to operate, is a probabilistic thing. It's saying the probability is suitably low at safe to operate. So there's naturally a bit of a disconnect. What we're trying to do in this work package is get, firstly, better guidance on the use of probabilistic assessments for supporting structural integrity safety cases, and also get wider acceptance of these approaches. And what that can deliver for AMR vendors is about having a better understanding of where the risks are in their plant and optimizing the design to basically optimize reliability. And that could be tied in with the inspection rates and things like that. So this is being pushed forward by Rolls-Royce, and there's lots of parallels here with what they want to deliver for AMRs and what they also want to do for SMRs as well, where they think actually they're putting too many margins in some areas, and effectively other areas they may want to rebalance and how you optimize safety. So I think there's a lot of value there. Work pack 2 is all around thin section defect tolerance. So a key part of this is looking at the OPEX. So the AGRs is one key bit of OPEX, but there has been a number of high temperature reactors built around the world, Gen 4, typically sort of test type reactors, and the reliability of those have been awful. And the reliability has been awful because typically heat exchanger problems in a lot of the designs. And that is because you've got creep fatigue interaction, naturally they're thin, naturally they see big temperature cycles, and high temperature degradation, environmental effects, creep fatigue effects, tends to make them a weak location. So one thing in, as I said, the UK regulatory framework is we need to consider defect tolerance. So as soon as you have one boiler tube leak, or heat exchanger leak, then the regulator will have to say, well, now you've got a population of defects, how are you going to manage that? So heat exchangers are a safety critical part of the reactor, because obviously it takes the heat out of the core, but actually you've got thousands of them in there, so an individual failure doesn't really cause a problem to the integrity of the overall system. But you have to manage that in terms of how can we prove that it's safe. And one of the key things around defect tolerance, and that's fracture and crack growth, nearly all the data that's generated is done using CT specimens like this, which are chunky, high constraints. And there's a lot of work out there, at low TRL level, that shows that that results in very conservative estimates of basically defect tolerance in thinner sections. So basically the defect tolerance of a thin section should be significantly better than we're currently assuming in the codes and standards. So this is all about developing that. So it's a significant test program looking at fracture and creep crack growth in thin section components to see if advice can be improved to improve the margins in that area. Work pack 3, creep fatigue. As I said, creep fatigue has been blamed for a lot of the problems seen in Gen 4 reactors, and also one of the major concerns for the AGR fleet that we're currently operating. What we do in the UK is quite different from what's in the design codes, which we believe is highly conservative, and we really struggle to see how AMR designs can use those design codes and get a satisfactory answer to get something that can actually be commercially operated. We've developed the R5 procedure over 30 years to help improve the methods in this area because it's crucial for operating our current plants. However, one of the things we've discovered recently in the picture in the top right-hand corner, all the codes and standards currently are based on stabilized properties. So that's kind of what the long-term state of the material is, how much it hardens up or softens. And what we can see in the top right-hand corner is it actually takes a long time. That's a cyclic test. So number of cycles along the bottom and basically the strength of the material on the top. It does get harder, but actually for a lot of the life, if you don't have a lot of cycles, it can be quite soft, which means we're massively overestimating the stresses in these components, and we think there's a large margin that we can take benefit there if we improve the quality of the models. So that's what we're trying to do in that program. The other important thing about that is we're focusing on austenitics as a key material for AMRs, but we're also looking at alloy 617 and HIP alloy 617. So this is an example where new methods of manufacture are being considered, and we're considering what actually the structural integrity impact of those improvements are, or those different fabrication methods. Does HIPS material behave anything like the wrought equivalent? Because if it doesn't, that's a lot of extra testing you need to do to justify the safe operation of that material. And then the final work pack is all around the codes and standards. So that's about what's out there already, how does it meet the ONR requirements and the ONR safety assessment principles, what are the shortfalls, if you're about to go through GDA, what do you think you need to have in place? So that's really about the guidance, and I'll say a bit more about that because that's really important for how it interacts with, hopefully, people in this room. So this headline document is all about the things that the AMR vendors need to consider. And it's also really identifying whether they're actually, what's available currently is fit for purpose or is more work required to get to this point. So this is going to address things like, well, what is the GDA process and what are the ONR expectations? I've already set out that the ONR has different expectations from other regulators. We're going to do a benchmarking exercise and comparing what the different design codes, predominantly RCC MRX and ASME, can do for you, and differently what R5 and R6 can do. It was really going to draw on what the operational experience has been from the AGR and Gen 4 plant. And I think the key things there is creep fatigue, heat exchangers, big problem, environment, really big issue, and also weldments, which are, once again, failures always happen in welds, and that's something that's really not addressed very well in design codes. And then finally about how the codes and standards that are available can be used, and then crucially what might still be the shortfalls. For this document to have any credibility, external acceptance is key. So if EDF Energy put out this document, you could probably shoot it down quite quickly by being a self-serving sort of document. But therefore, key stakeholders include sort of the ONR, and we talk to them regularly about the development of our own procedures. So we've got good communications there, and they're interested in being involved in this. We also need to make sure that the design code developers, i.e. RCC, MRX, ASME, are also happy with what we're saying, that it's consistent with their view of the world as well. Because what we really don't want is putting out this document, then people disagreeing with it. And then crucially, AMR vendors, and hopefully there'll be an opportunity today to make a few more contacts there. So progress to date, we're generally a bit slow signing stuff off, but we got there in the end. Technically on work pack 1 to 3, I consider work pack 1 to 3 to be kind of effectively normal business in terms of developing technical innovations, and they're progressing quite well. We're sort of getting the test programs are underway now, and things are going to plan. More interesting on the external engagement is around what we're doing in work pack 4. So we've already got a skeleton for what this guidance document is going to actually say. So we're going to send that out in a sort of skeleton form to, crucially, people like the ONR and these external experts to say, this is what we're planning to do. Do you think it fits the bill? And AMR vendor feedback on that will also be really valuable. We're doing this benchmarking activities already, trying to set up contracts now with both French and Americans to be able to actually give them the time to review this document and make sure we've got their sign-on. And National Nuclear Labs, there's a typo there at the bottom, National Nuclear Labs reaching out now to some of the AMR vendors to try and get greater engagement there as well. So that's what they'll be leading on. This is just a bit about what we're planning to achieve at the end of the day. So hopefully by the time we get to the end of March next year, we'll have a series of technical innovations to support the AMR process. They'll be sort of published, disseminated, and included in some of the UK assessment procedures where appropriate to get international sign-on to those. We'll have this guidance document that will be available for public release, and crucially, everyone's happy with that, and it has a kind of consensus view of the current state of technology. We'll have developed those skills that aren't available at the moment, especially around the testing element, and people will actually start picking up this document and hopefully making use of it. And the end goal, which is one of the driving things around the nuclear innovation program, is delivering cost reduction. So I see this as a major risk to delivering AMR technologies. If you come along this challenge too late and you realise that we need more testing, especially we're talking about creep here, when we're talking about creep lives of 60 years, to generate enough data to give you confidence the materials you want to use are fit for purpose, you can't do that quickly in the high temperature regime. So understanding what those requirements are as soon as possible can only be a good thing in terms of bringing forward that GDA process. And I think that's where the big cost saving is here. So one of the things I was asked to comment on in the scope for this presentation is what we think the follow-on work might have to be. Now, I think it's almost certain that with the current codes and standards that are available, there will still be identified shortfalls. Most obviously, the shortfall around environmental effects. Each of the AMR technologies that have been sort of put out there, each have their own unique set of environmental challenges. So that makes it really hard to generically address the problem. And the other thing there is around materials data. So if you're proposing new materials or new fabrication methods, it's a new challenge in terms of demonstrating the integrity of that for long-term creep behaviour. And the other thing that's a bit more fundamental, and this is really for the stakeholders to consider, especially people like the ONR, is that the conclusion of this programme will almost certainly say, yeah, you can use RCCMR or you can use ASME, but that on its own is not enough. You'll have to do something extra. In fact, that's kind of what happened for Hinkley Point C even on the PWR side. You have to do something above those procedures. And chances are R5 and R6 might be able to fill some of those gaps, but I don't think even that will get you the whole way. So we're going to end up with a kind of a patchwork in terms of what codes and standards are required. And I think it's up to the UK more widely and the people here to decide if that's the solution that we're happy with or whether we want to do something a little bit better and bring that together. So that's where I think we might be at the end of March next year. Thank you very much.
Thanks very much, Mark. Right, now is your opportunity to dig a little deeper. There's lots of technical aspects to consider, but perhaps you want to know what it's been like working with BEIS, working with these contracts. And as I say, it's your opportunity to learn from these guys if they're able to provide the answers. So just to show hands in the room, is there any questions? There are some questions. Mike, have you got some questions? Right then, what I'd like to do then is invite Mike, Mark and Jamie to take a seat there, please. So Natasha will be around with the roving microphone. The microphone there should be working as well. I'd please invite you to, when you have a question, to state your name, your organisation and who you're addressing the question to, or it might be all three. But please wait for the microphone because, as I say, this has been recorded and we just want to pick up your questions and answers. Okay, I'll go to Mike first. Have you got, how many questions have you got, Mike?
I've got 6, I think, now. So
6. Let's have first 2 from you then, please.
Okay, so we've got Andy Hanratty. It's really more of a comment saying the industry is crying out for modularisation. And Jamie Towns, the quality control aspects of transporting and assembly components is really interesting. Is there an output of this project?
Is that for Jamie?
Is this on? Yes. Hello. The output of the project is that we're creating a transport integrity plan. So what we're doing is we're working with an SME who specialises in this kind of area, and they're coming to us with an idea of what kind of sensors to use, how they're going to actually interrogate that data, and how they can come up with an approach that actually proves that it is as it left. Does that answer the question?
I'll get them to come back with a comment if it doesn't.
Yeah.
Okay, perfect.
Okay, we'll take one more, Mike.
I'm going to throw one in from myself, actually, because there wasn't many at the time. The digital twin you talked about was really interesting. Are you working with the Cambridge Centre for Digital Britain on the twin?
For the digital twin, we're working with NNL. So NNL have I think Mike Jury is here, but they're working with, is it the Virtual Engineering Centre in Liverpool? So what they're doing is they're coming up with a CFD model, which is working with digital twin, but also looking at if they make any changes to the flow rate, for instance, then you can go and check your system and you see if the associated, let's just say, pressure drop is as you would expect.
Okay, that's excellent. Just to add to that as well, so the Virtual Engineering Centre of Liverpool, VEC, they're part, there's another group that we run, it's called the Digital Special Interest Group. We run that on behalf of the Nuclear Institute, and it has digital leaders from across all stakeholders. So further information on that, please come and see me. But the idea is to bring in that expertise from outside as well and share best practice. So just a little plug there. Okay, question there.
Hello everybody, Ram Shankar from Equitas Engineering. This question is for all three of you. Given there's a deadline on February 19th and today is Suppliers Day, what opportunities, if any, exist for suppliers to come on board the February 19th opportunity, or are there none and today is just more of a box-ticking exercise? Apologies for the bluntness.
Well, I guess there's a question now, but then there's a question following the briefing on the current call, because I guess very much is how you want to engage with, if you like, the collaborative sort of proposals following this call. Yeah. But anyway, any comments on how new suppliers can engage?
Yeah, I think these kind of calls provide great opportunity, but I think for successful calls, and not just in BEIS but in everything, building on strong collaboration has to be kind of demonstrated. I think it's a really important part. Starting something brand new on what is a very short program, if you're starting from a cold start, I find it really hard to see how you can really deliver value in that time, and that's what BEIS are really looking for, delivering value. Is that fair to say?
Well.
So that's my view, but I hope, although it's not been mentioned yet, that this is not the end, and there'll be things in the future. And I think if you always wait for supplier days to try and start, you might always be up against these tight deadlines.
Yeah. Well, what I would say is that, but obviously driving down costs and working across sectors and identifying best practice. I guess the SME that you work with from the shipbuilding side, bringing them into nuclear to look at the transportation aspects, is a good example. So we should be looking perhaps across identifying those key capabilities, best practice that other sectors can bring to bear. So any other comments on that question?
Yeah, I'll also say that these projects, they're going to hopefully, all come to fruition, they'll be a good step forward to improving all the manufacturing capabilities needed for SMRs, AMRs, but they'll not address everything. So like I said, there will be future calls, there will be future work. So even if, for example, you don't go in on phase 2B, just make some contacts, make yourself known. You never know what comes up in the future.
Yeah, and certainly use the KTN to facilitate that.
It really depends on what you're offering as well. So, for instance, if you are offering a service to a currently existing project, sometimes the budget has already been allocated, but if you can get involved early enough, or even identify an area where you can add value, or even if you want to use some of your own funding as well, it may be beneficial. So those conversations need to happen. So for instance, with us, we're still looking for some suppliers for certain bits of materials, because we're still moving now into the detailed design phase going forward this quarter. So if you've got anything that you could offer to help, we're all ears.
Sorry, we've got a question from the back.
Chris Peters from UKAEA, with my Fusion hat on. And just a question for Mark mainly, I think. Your world is mainly structural integrity, presumably for fitness for service, ongoing fitness for service. Is there anything that you see now that you think, I wish we'd taken care of that at the design stage? Yeah. And would you, if the answer is yes, would you advise that we start looking at structural integrity aspects right now for fusion?
I would strongly agree with that. I'm pretty sure I would like the whole R&D program we're currently doing to have been done 30 years ago, ideally. But as people have said, if we waited till we knew everything, we would never actually build anything. So one of the key things, especially, and it's going to be linked to fission as well as, no, fusion as well as fission, is monitoring schemes. So when the AGRs were built, the appreciation and need for monitoring schemes were really valued to characterize long-term behavior, because you're never going to generate 60 years of data before you start operating a reactor. You want to last for 60 years. The problem with the AGRs, when the CGB set off with good intentions and then privatization happened, and a lot of those programs got scrapped, and now 10 years down the line, 15 years down the line, we're trying to play catch up. So the value in monitoring schemes, I think, is really crucial. And I think that is one area we can really benefit from the AGR experience. Just more generally on links to fusion, UKEA are getting more involved in this sort of structural integrity area. So they're joining the R5 assessment procedure, for example, because they are starting to think about those practical calculations that they'll have to do to demonstrate safety and the challenges that come with that. But yeah, I'm afraid there's a whole host of things I wish we knew 30 years ago.
Any more questions? So, sorry, can you just wait for the microphone, please?
Sorry, Stuart Gallagher, Moduling Systems Limited. I've been involved in a number of years in modular construction. I'm involved in N690 as part of AISC that provides guidance in Chapter N9 to the construction of SC systems. In terms of internationalising your reactor designs, it's almost a general question. In the US, you know, it's a prescriptive procedures that they have, but it's also bound up in federal law. So if you deviate from that, it's not actually, you're breaking federal law, you're not just differentiating in terms of you think your method's better. So in terms of getting stuff through an SC modular construction through the US NRC, it's taken quite a while. I mean, Westinghouse started modular construction in the nuclear industry with the AP600, and when they did the AP1000, they didn't have a design that met what we'd say would be N690 principles. And N690 has a chapter in the ISC, and it's just about to be accepted by US NRC, as I understand. So that's been a long process. And some of stuff of what you're doing, particularly in the codes and standards side, I'm wondering what the timeline would actually be to get some of this accepted, especially if you deviate from deterministic code-based methods that everyone's familiar with. So how much do you think you need to push it to get your designs accepted? And, you know, in the timeline that we're sort of expecting in terms of UK rollout, and do you believe you'll be able to internationalise your designs and get it through the other regulators who do tend to differentiate in terms of their acceptance or not of design work?
Okay, I think there's quite a few aspects to that question. So if we start with the difference between the UK regulatory framework, I think the way it's set up in terms of goal-based does actually give you the flexibility and opportunity to innovate quicker, as long as you've got the scientific evidence behind it to be able to support your...
I think that's fine from a UK perspective, but having dealt with US NRC and serving some of the US committees,
Yeah.
I think your optimism may be misplaced.
Oh, I have... No, it's not.
It's just a challenge.
No, not at all. I've been very much focused, both my presentation and that what I've said there is around UK application. If you're trying to address the designs in the US, I agree, they are painfully slow. Everything is done by committee, and as a result, it takes a very, very long time.
Yeah,
I have not even considered how long. We have been contacted by the US NRC because they're thinking about what they do for high temperature reactors.
Well, the problem is if they delay it too long, we'll never meet 2050 with anything.
Yeah, well, some of the American companies have very ambitious timescales in terms of building things in the US, and reading between the lines, I don't think the US NRC know how they plan to regulate it. So it's early days in terms of our interaction with them. We have no intention to really try and influence the US regulatory framework. Absolutely no intention, in fact. We're very much focused on the UK. But if you're looking for a reactor design that is accepted internationally, you've got a real challenge there, because everyone does things differently.
It's not a simple, straightforward process.
Okay.
But I think there's equally an opportunity, because of the UK regulatory framework, to potentially do it a little bit quicker.
Okay, that's a good point. Well made, thank you. Okay, Paul?
Paul Pearson from Kellogg's Brown and Root. My question is quite similar actually to the previous one, but it was more from a fundamental element. There are other high temperature reactors that have operated in the world, particularly in Russia and in the States. And what interactions have you had with those from some of the high temperature liquid sodium reactors that have operated previously? And then secondly, it was, you're intimating that you can reduce the time for GDA. So I suppose the fundamental issue is by how much? Because the GDA process is still 4 years, and I think everyone has a great expectation that the development of SMRs will be quicker than a large-scale sort of 3 gigawatt plant. So have you had those discussions with O&R in terms of timescales and interaction?
Could I just add one? There's a similar question here from Jamie Townsend. How is the UK learning from other operators of Gen 4 plants in terms of codes and standards, e.g. Russia and China?
Yeah, so hold on, once again, several aspects to this. So we start with the GDA thing. I think the key thing, I know the ONR are reviewing the GDA process at the moment, whether that could be streamlined. I think my key point about bringing GDA forward is getting to the point of starting GDA. There's nothing in this about speeding up the process of GDA itself. So it's about the AMR vendors being ready to start that process. So that was my comment around delivery and sort of delivering things sooner. The second aspect about learning from internationally, through operating at the high temperature plant, there's been very good communication, I think, between EDF and the predecessor companies and other operators. Mention of Russia and China is probably where there's been least interaction. We've talked to the Russians rarely, although they have some very similar materials and they've operated some high temperature plant for a very long time. The level of openness has not been strong, and to be honest, we haven't pushed it at all in recent years. Similarly, China are really pushing forward with a number of high temperature reactor designs. They've tried to engage with us in several ways, and we've talked to them, but it's been very much at a kind of almost an academic level. There's been no real discussions around regulatory or sort of end product sort of thing. And it's obviously something you could do more. It just hasn't really aligned with our requirements so far.
Okay, thank you. So, go on.
I did actually have a question for Michael as well. I did get an impression from your presentation, which was fantastic, thank you, that your electron beam welding is undertaken in a vacuum. And if it is, then is that size limiting? Because I actually was thinking of an application of the hulls for nuclear submarines, 32-foot diameter, fairly thick NQ1 steel. It would be an ideal application, but it's fairly difficult to get a vacuum that size.
Yes, yeah, it is. So just come back, electron beam welding has to be conducted under a vacuum. So the way we're approaching it was with local vacuum. So rather than sticking the whole thing in a big steel box and sucking all the air out, like traditional electron beam welding, it's build a localized jacket, a very small vacuum volume around where you're welding. So would be a challenger for a submarine, I think. Okay. I'll take the baby steps first, maybe scale up to that.
Okay, thank you. Mike, have you got any more questions?
Yeah,
a
few more here. So first of all, from Andy Havrati, is more a comment really. Similar processes to manufacturing explorative satellites where different components are made by different teams contributing countries. There could be experiences, have we learnt from them? Which I think is probably more a comment. And then from Jamie Townsend again, is EDF or the consortium working with any high temperature AMR vendors who might deploy these technologies in the UK? Is EDF considering being an operator of such plant on the future?
That's above your pay scale, Mark.
Yeah, it definitely is above my pay scale, that. In terms of engagement with vendors within this program, that's really important. That's something NNL, National Nuclear Labs, are pushing forward with us. We were kind of hoping that the AMR competition would progress, which would narrow down or prioritise who we talk to first. But we're obviously making progress in that direction in any case. In terms of long-term ambition, AMR Technologies, I think, is suitably far away. I don't know, well, recently EDF France has pulled their funding for Astrid. So they've obviously put AMRs on the back burner for the time being. And there's no similar activity in the UK currently. But as the major operator in the UK, I think we're interested in keeping in touch at least with all the technologies that are being developed.
Okay, excellent, thank you.
Got one last one from Kevin Lewins. Could ONR become the codes and standards for organisations similar to DNV, Lloyds, etc., in oil and gas?
I don't know if anybody from ONR is here able to.
It would be a significant deviation from how they currently regulate. Now, like on my last point on my last slide kind of said maybe there is a better way of doing it. One thing I will say is that the UK operator in the UK, currently EDF and obviously predecessor organisations, have basically been the only large operator. Well, obviously there's Magnox as well, but they all came from the same place. If you're moving to a situation where there are a number of smaller organisations, to ask each of those organisations to have the technical capability to act as sort of a developer of codes and standards for their own purposes, that's quite an ask. So it may be things do need to change in the future, but that's really a question for the ONR, I'm afraid.
Well, or we could ask UK AEA to take up all the codes and practices again. But did you a question here?
Dilks, BEIS. I suppose a process question to all three of you. If you could skip back about a year, what one piece of advice would you give to yourself about going through the grant application process and getting to the point where money was coming out the other end?
Oh, go on. I'll go first then.
You could be honest. You're amongst friends.
To be very honest, it would be on the EDF energy side. EDF are a large organisation not geared up for this sort of stuff. We just haven't historically applied for grants. Therefore, when you put a bit of paper that's good in front of a senior manager and say, will you sign this? We're getting lots of money out of it and it's really good for the business and really good for our reputation, really good for the UK. Everyone agrees it's good, but no one's willing to sign it because they've not signed it before. So yeah, that would be my advice. So if you're a small agile company, that's probably not a concern. If you're from a larger company, understanding that before you get going would be really helpful.
So I'd say Forge Master sort of fits in between what you just described there. So we've had experience with the smaller companies. They're generally not geared up from the legal perspective to go through the contracts and get that all signed off quickly. So if you're a smaller company, you don't have a lawyer in-house, get yourself one lined up before you start applying. But we're sort of medium-sized, we could get it through our board. At least we've got experience of doing these sort of things. I'll be frank, going through the BEIS process at the start of the project, used quite a few months at the front end. Probably shouldn't be saying that, I'm submitting an invoice at the end of the month. But yeah, so be prepared that your program's going to be shortened a little bit because of getting through the whole process. The financial due diligence was mentioned earlier. It's got to happen. These things have to be done. So just make sure you've got a bit of contingency that you can either accelerate your program or you can get it done in a short amount of time.
Mm-hmm. That's exactly what I was pretty much going to say. It comes down to your plan as well. So your plan needs to be robust because essentially what will happen is you have a number of different times where you get pushed back. So your program's always going to go to the right. So just make sure that you have enough leeway in there, that you understand what you're trying to deliver and get it delivered on time, because at the end of the project, that's the funding done. So you need to make sure it's all done by then, really.
Okay, thank you. Any further questions? No? Going on. Well, thank you very much then to our speakers and for answering questions as well. Okay. Now to the new stuff. So I'd like to invite Si and Will. Is it going to be Will first? Okay. So, yeah, about the current call. Okay.
Yeah. So I'm Will Ludlam, Project Manager from BEIS in the Nuclear and Renewables team. So hopefully that was useful, getting to listen about some of the previous projects, some of the sort of challenges within the industry that they're solving. Hopefully that was useful and might spark a few ideas. So I assume this is why most of you are here, about the new call. So it's Advanced Manufacturing Materials Phase 2B, but with a bit more of a focus on advanced manufacturing and construction. So I'll talk to you a bit about an introduction to the program, the objectives, the scope, and then what you need to do to apply. So as you've heard, AMM is a key component of the innovation program and sector deal. One of the targets in the sector deal is to reduce new build costs by 30% by 2030. So if you're going to do that, this is the sort of thing that is going to be key to that. So the 5-year outcomes for the AMM program, so that'll be finishing in 2021, are to deploy the UK's research capability to deliver new technologies, and also to develop and demonstrate a suite of advanced component manufacturing technologies to drive down costs. So that's one of the key components to achieve that 30% reduction in cost by 2030. And also to include modular construction into the nuclear industry, something historically has not been done, but we see in the Camel-led project, which has introduced that, so we're trying to build on that as well. So what's new with the call? So it's a narrower scope, so you'll see in a sec some of the sort of work areas which have been removed from the program, but these are materials, coolant chemistry, and codes and standards. And the new area is advanced construction. So this is to sort of bring it more in line with the sector deal, with the focus a bit more on the construction side rather than the materials. So the maximum award to a single project is 5 million. So that's half the total allowance of the total grant, which is 10 million. So we've applied new grant intensity limits to this in addition to state aid regulations. So you just need to make sure that you do abide by those as well as the state aid. And importantly, unlike the previous call, you don't need to have taken part in a previous phase of AMM. So we're hoping we'll get some new people in, some interesting ideas, and hopefully a bit of interest from the construction industry. So as I said, it's up to a £10 million grant fund to essentially produce a technology demonstrator or number of demonstrators that include advanced manufacturing and construction techniques. So a couple of examples: trial builds, facilities or rigs, which we've seen in some of the previous projects, some including modular construction, and also digital techniques. That's something which is sort of touched on in the Phase 2A projects, but we've not had a project which is sort of really focusing on that. So the aim of this is to apply these to new build, maintenance, decommissioning of power plants in the future. So why are we doing this? So the benefits are to the wider nuclear industry, but we're really trying to target this to sort of focus on specific areas in the advanced manufacturing construction work areas to sort of move that towards bringing them into industry and actually bring a benefit. So we really want to see a clear method of deployment. You've come up with this idea, how are you going to bring it to industry? So the EDF project sort of touched on this. Well, there's all these ideas coming in, but you need to show within your proposal how they're going to meet standards, or have an idea of how you're going to improve the knowledge you need to be able to meet the standards required to deploy these on a nuclear site. So these are the work areas you can see here. So your project must encompass at least one of these, but it could touch on a few different areas. So you've got nuclear component manufacturer, large-scale nuclear component, manufacturing and assembly, manufacturing modelling, prefabricated module development and verification, and the new work area, advanced construction. So there are some examples of outputs and strategic outputs of these within the call guidance. I would recommend you do look at these. They might sort of spark a few ideas and give you a good indication of what we're looking for. So this is an overview of the programme. So you can see phase 1 here was £5 million, and we're sort of in the middle of this. So phase 2, £16 million. So you've heard 3 of those projects today. And then this is phase 2B. So you can see here, these are the work areas that we're bringing forward from phase 2A and the new work area, advanced construction. And on the right, you can see sort of some of the goals of the programme and what we're trying to achieve over on the right-hand side in those 3 boxes. So this is essentially what you need to do to apply, or what you need to show to be eligible for the programme. So as I said before, you don't need to have taken part in previous phases for this programme, but we're hoping that people can build on the learning and experience of previous programmes and bring those into your proposals. So you must, as I said before, you must address at least one topic within the AMC or AMM Phase 2B work area, although it might be useful to cross over between some of those work areas. So one of the key aspects is reduction in cost. Your proposal must show a reduction in cost over traditional methods. So these might be construction, manufacturing, but you need to show that your idea is creating something new which is going to reduce costs of current methods and sort of contribute to that overall reduction in cost of new build. So you must meet regulatory standards and also use digital information support regulation, show that your ideas can be brought onto nuclear site and you can get ONR's approval to bring these sort of concepts into the industry. So another criteria is you must have the majority of your project activities must be located within the UK. So the Nuclear Innovation Programme is all about developing UK skills and capability. So that's why we're saying that you must have the majority of your activities within the UK. So projects can last up to 12 months. You've heard the deadline of our funding is to March 2021. So you can continue working past that, but we won't give you any money for it. So the maximum grant call for this project is £5 million, and this table here shows the intensity limits that we're applying. So these are slightly different to the state aid regulations. I think it's just these top headings here which differ from state aid. So essentially, depending on what your consortium is made up of, there's slightly more stringent conditions applied to that, but you must also look at the state aid regulations. So both single company and consortium bids can be considered, but you must submit your application from the lead project member and include all your finances from other partners within the consortium in the lead partner's proposal. So members can include UK registered private companies, both SMEs and large companies can apply, and the grant intensity limits you saw before would be for the whole project. So although state aid regulations would say that larger organisations can only apply for a small amount of state aid and universities can apply for more, you must work within these conditions where your total project can only have a certain intensity limit, and within that you have to divvy up your funding as you see appropriately. So as I said, UK academic organisations, research, public, third sector or community organisations can take part, but they cannot be sole applicants to this project. They must be part of a consortium. So the same applies to international organisations. They can't be project leads or sole partners or sole applicants. So they must be within a consortium led by a UK registered company. So the project consortium that you put together, you must have the capability within that organisation or consortia to deploy whatever you're proposing. You can't just propose it and then sort of say, here it is, this is what we've done. You must show how this is going to be brought into the industry and have a plan to do that. So in terms of submitting your application, you've not got too long now. So Si mentioned why this has been a bit sort of tight schedule. So 19th of February to submit your applications to the nuclear innovation at beis.gov.uk. So in the call guidance, it gives a bit more information about some of these forms. So you've got the application form, partner details form if you're a consortium, finance form. So if you include this for your whole consortium rather than one for each project partner, and a Gantt chart or something, just show your project plan as you see appropriate. And also letters of support from collaborators or partners also make it much quicker in the stage of bring contracts together in the later stages. So there's several sections within the application form, so you've just got to make sure you work within the limits of each section and don't exceed that. We will accept additional information in further annexes, but you've got to make sure that you don't rely on this information. We will accept it, but we can't guarantee that it'll be included in the assessment and moderators by BEIS and third-party officials. So just make sure you do that. So today, 30th of January, is the information day. And then the deadline for applications is 19th of February. So your assessments will be assessed by BEIS and third-party assessors, and we expect this assessment process to be complete by the 4th of March. And we will then inform applicants a couple of days later, expected the 6th of March. So we're hoping this will give enough time to get contracts in place to start on the 1st of April. Hoping. So I'd like to invite Si back to the stage for Q&A. Yeah.
Okay. Again, your chance to ask the BEIS people those questions. So, any questions? Okay, Mike. Sorry. Yes, please. Yeah.
You mentioned in one of your slides about approved standards. Exactly, what do you actually mean by approved standards in terms of nuclear industry in the UK?
Was that the slide?
I think it was the second slide. It was fairly. It's further back.
Yeah, back one.
Other way. All right. Forward. That's the one I went to.
I can shortcut that. It's around the kind of discussion that Mark raised earlier. It's regulatability. You must be able to show that what you are proposing in terms of your technology is not so far out of the norms and standards that you believe the regulator would apply, that the regulator will never even enter the room with you. So we're not setting very specific codes and standards. What we're trying to talk about is the regulatability, what you're doing.
I'll give you an example. The only approved standard I know is the ISCN 690 for SC construction. So is that the one I should propose?
I think looking at this one as well, it's quite
Sorry, Bart, can you just take the microphone, please?
Because I did look at this as well when this came up in terms of what those standards actually say, and I think particularly if you look at the NIA 1965 license condition, that is actually just a list of more of activities that will enable, from what I read, enable the regulator to engage with that project. So a lot of that is about sharing that information, rather than reading that as a whole suite of nuclear standards that need to be met, which, as you say, might or might not be there. So it's quite a specific.
Well, we just gave a
question.
course to the regulator on the ISCN 690, so I presume he would accept it. Is that correct? And you would accept it if I used it?
Well, yes, if it meets that license condition there, it's a matter of. I mean, I'm not.
And what I'm trying to say to you is, when AP 1000 didn't use the most recent standards, and it went through the regulator, okay, yet the standard proposed wasn't specific. And given it's a non-prescriptive body, then it's really up to you to justify the standards that you use.
That's pretty much what I was just going to say.
Yeah.
If there are recognised standards and you can work to them, it's easier for the regulator. If, however, you can prove that what you are doing meets a similar standard or excels it, then, again, the duty is on you. So what we're generally talking about is regulatability. Can you show that you are matching or exceeding either a recognised standard or something that you think the regulator can tag on to?
Well, I don't think I'll be taking the second option, given that there's a perfectly good first option that's gone through Yes NRC. So, but thanks for the response, Annie. I appreciate it.
Okay, Paul.
It's for Sil, I guess. Sorry. The current round of funding for the Nuclear Innovation Programme was from 2016 to 2021, so this is the last tranche. Is there an anticipation that there will be another funding from the government? Because nuclear hopefully will be an element going forward for the UK energy mix. So will we go for another round of NIP?
I very much hope so, because otherwise I'm out of a job. We can't give any guarantees, but we have a new government in place. We will be having a budget on March the 11th, and we would expect, as in line with recent history, that there will be a spending review and a 5-year budget set at some point this year. So all I can say at this point is I'm working very hard to try and convince people at Treasury that there should be a Nuclear Innovation Programme Phase 2. And we are working with NIRAB and with various other organisations to collate the evidence base for that. But what I would say to you is, if you want one, be noisy about it.
Yeah. So.
Hi, it's Greg Ashes from Cavendish Nuclear, and hi, Si and Bart. I was in BEIS for 3 years before I jumped back out of Cavendish Nuclear, so nice to see familiar faces. A couple of questions, please, about the grant call. The first one is an organisation able to lead multiple projects, or do they have to be kind of leading one and part of a second one? So just some clarity on that. And then the second one around use of subcontractors. So when it comes to the grant intensity, I get that the overall mix of the share has to be in line with the grant intensity limits that you've set. In terms of using subcontractors, are they able to recoup kind of 100% of their costs rather than have to abide by the same grant intensity limits?
Yes, so they'd have to take part in that overall intensity limit. You can't just sort of apply for funding base and draw down 100% just for subcontractors. So you would have to abide by that as well.
I forgot the first question.
Multiple so projects. Can you apply for more than? So can the same organisation put 2 applications in?
Yes, you can put multiple applications in. All of them just need to fulfil state aid, really.
And as lead?
As lead, yes. We did last time. We saw multiple organisations put in single organisations putting in multiple applications. Caveat I would add there. From the learning of the last one, if you're going to put in multiple applications, make them all as good as if you were just doing one.
Will there be? Sorry, just to caveat that, would you look at deliverability if you're able to deliver?
Yeah, I mean, we will consider within that. We'd like you to justify how you would be capable of delivering more than one. It's one of the things we'll be looking at. But yes.
Put one in from the. We've got Robert Cooper. How do universities submit their finances? Is it through the JES system or provided finance form?
Through the finance form, as that is the thing we will be looking at. It's very much to the universities and the other consortia to present the information to us in the form required. And to tell us what you're going to be charging. Keep it as simple as possible would be my advice.
Okay. Any more, Mike? No? Any more from the room? Yeah. I'll take Mike first and then the gentleman next time.
Hi, Mike Lynch from Wood. Just a quick question on partners and subcontractors. If we've got partners and the lead organisation is putting forward the finances, will the due diligence be on just the lead partner or all the sub-partners as well? And is there a difference between subcontractors and other partners?
So it would be on the lead organisation. We'd expect any project partners to be in place in the proposal, but subcontractors, if they're only delivering a small part of the work, we might not expect them to be in the proposal. It could be addressed during the project.
Okay.
Hi, it's Ian Jackson. I'm acting for BEIS for France, but it's a question for Si. Si, it's a question on the intensity requirement. Does, for want of a better word, does the sort of contribution of the consortium, does that have to be in cash, or can it be substituted for some background intellectual property? And I mean, we can discuss it over lunch, but I'll tell you why. You know, we've got some military technology which would fit very well with this project, but it has a certain value, associated with it. Could it be used in this context?
I would say read the state aid guidance.
Oh, great.
We can only scratch the surface of state aid. It is quite clear on contributions in kind are very hard to justify under the state aid guidance. So it depends on how you're going to present that, but read in detail the state aid guidance on that, as that will be the main stumbling block for you.
Okay, so in kind is tricky.
In kind is very tricky.
Yeah. How would other consortia normally do it? Would they provide time?
Time, resources, people, cash, in-kind information, things that you already have are very difficult through state aid. They're not impossible, but again, read the state aid information. It goes into great detail, and there is much legal discussion around what it means.
Okay, thanks.
To add to that one, the in-kind with state aid also depends on what was behind that in-kind in the first place. If it's something that has already received public funding of one form or another, that makes it even more complicated. So just to be aware of that.
I think we'll forget in-kind. Thank you.
Okay. Any more questions? I can't see any. So, yeah. Well, that's a wrap. Okay. Thanks very much, guys. All there's left for me to do now is to bring this to a close, to reiterate that all the information will be with you by early next week. We are early for lunch, but we've done very well. So just to reiterate, lunch will be available just outside at 1 p.m. Oh, Norman, shout louder.
Thank you. This is not a question, it's a piece of information about a new development which could have a great impact on the people in this audience. I'm one of the UK experts on the ISO committee that develops the standards for digitalization of all product data. And there's been a new requirement from the Chinese to have a new international standard for the handover of nuclear plant when it's completed. And the requirements of this handover standard is that all the information about the plant should be digital. And the requirement is probably going to look as using the standards for digitalization of product and product data from the ISO TC184 SE4 as the basis for the handover information. So this has a possible impact on all suppliers of nuclear components and nuclear plant. They're going to have to comply with the standards for the descriptions of items as part of the handover procedure. And this standard is originally proposed by the Chinese. We've got an ad hoc group that's investigating the feasibility of this. The convener of the group is from EDF, and the people part of the group are from South Korea, China, Japan, France, Holland, Sweden. I'm the only UK representative on this group, but it is quite clear that the Chinese are, and the rest of the world is moving towards a totally digital representation of the nuclear plant. And this will have an important impact on all suppliers of components to nuclear plant. So I thought this would be a good opportunity to warn you about this development, and we can provide more information as how this will develop if people want to talk to me about it.
Okay, so yeah, contact Norman if you want further information on that. For Norman's contact details, please contact KTN, myself, and we can either put you in direct contact, or Norman, if you've got some further information, we could disseminate to the group and our wider communities. Yeah.
Thank you.
Okay. So, Si.
Off the back of that, again, if you need any further information from us, drop us an email to the nuclearinnovation@beis.gov.uk address. The questions from today and any questions that we receive on that before... When's the deadline for questions? There's a deadline for questions in the guidance pack. Thank you. Will then be published on the web to give you all sort of equal information in your bids.
Okay. So I will wrap up now. Excellent. Okay. So thank you all for coming today. Thanks for all your engagement and questions. Thanks to everybody that's joined the webcast, again, for your questions. You can now go and put the kettle on and go and have lunch yourself. As I say, lunch won't be served till 1 p.m. down here, but you can either stay in here or you can go to the second floor, help yourselves to coffee and start all this good networking stuff. But other than that, the formal part today is finished. So thanks again, and wish you a safe journey home and good luck in the competition. Thank you.